Hi everyone. In the last video, we talked about the loop for. Today, we are going to talk about the loop while. And while it can be applied in the same situations in which the loop for applies to, but differently, it can be applied in situations where we don't know the interval where the variable is going to be applied, and in situations where the step between the values of the variable are not constant. Before we start, I would like to ask if you think this subject is interesting. Please click the like button and consider subscribing to the channel. And let's start. So I have here two simple examples to apply the loop while. The first of them is a simple count, the same situation in which we applied the loop for. And different from the loop while, we have to start the variable before the loop. And after while, we put a condition and we put after the word do as a command or as a block of commands that are going to be executed while the condition is true. So in this case, we are going to put to print the variable and the way the variable changes. So here we have a simple count. If we would like to make a countdown, for example, we could make something like this. There. So we can see that the main difference between the loop while and the loop for is that we start the initial value before the loop, and the way the variable changes has to be put inside the loop itself. A situation that is very interesting to apply while, but it could be more complex to apply the loop for, is to generate a geometric progression. So in this case, for example, let's start defining an empty list, and let's put that the initial value of the geometric progression is 1, and let's say that the geometric progression is defined so that its last element is not bigger than 10 to the 6th there. So we are going to put as comments this command that is going to add the element of the geometric progression to the list, and then the way the elements in the geometric progression change. So 2 here is the common ratio between the elements there. So we have defined our geometric progression. There it is. We have seen that when we have a list, we can make many things with this list. For example, I could try to see what is the 10th element of the list there. I could, for example, determine the size of the list, how many elements the list has, and also we could compute the sum of the elements in the list there. We could also create ordered pairs with this loop, but we have done this in the video with the loop for, so I'm not going to repeat this. We could also put if inside the commands in while, but we have done similarly in the video where I talked about the loop for, so I'm not going to do this again. But one interesting situation to apply the loop while is, suppose, for example, let me insert an image here. I want to define the cosine function with this series, but of course, we cannot sum an infinite number of terms, so we have to truncate the series. And in order to do so, we are going to choose the number of terms so that the last term is not smaller than a certain tolerance. For example, let's define the terms. The function that is going to describe the terms of the series. We have something like this. There. And suppose that we want that in the maximum value of 2 pi, we want that the absolute values of these terms are not smaller than 10 to the minus 6, for example. So we can make something like this. I'm going to start my variable, and I'm going to tell Wiley that while the absolute value of these terms in the maximum value of x, they have to be bigger than 10 to the minus 6. And then we are going to increase the value of the variable so that we can, Wiley can tell us how many terms we need to have in the series. So in this case, we need to have 14 terms. We can then define a function summing these terms. So we can have something like this. There. And we can compare this function with the cosine function defined in Maxima. So let's use a draw to make this. And there we have a graphic comparison. And if we zoom in some interval here, then we see that the curves, they are very close to each other, so we cannot see the difference. If we extrapolate the comparison to values much larger than the maximum value of x, then the comparison is not good. So it shows us that the precision of our function is not good. If you want the precision to be good again, then what you should do is to change the maximum value of x here, and then while it tells us the number of terms the series has to have to be precise inside this new interval. So this is what I would like to tell you today. I hope you think this subject is interesting and that you can use UI in your work. So thank you for watching. See you in the next video.